Hello there. So today we're going to talk about Flamanville, the newest French reactor that just came online. So first we take a look at the plant itself. As you can see, there are three nuclear power plants at the Flamanville site. I believe that the most right one is Flamanville 1, then the middle one is Flamanville 2, and the third one on the left, that is Flamanville 3. Now, Flamanville is located on the west shore of Normandy. So you have the landing beaches where during World War II on D-Day, the Allied forces landed in France. And then you have this peninsula going up. And then on the west coast of the peninsula, that's where Flamanville is situated. Now, as you can see, I mean, they look very much alike, these three nuclear reactors. Obviously, the Flamanville 3 unit is much more modern than the other two, but you can clearly see a similar design philosophy. Now, the interesting bit is, basically, you can see the large black building that is, that is to the south. It's actually to the west of the containment dome. That is the turbine building, and it is huge. It's an absolutely massive turbine building. But, you know, the turbine that's installed in there is capable of delivering 1,650 megawatts of power. So that's amazing. Then to the right, you can see that's the transformer station that is there. That is, you know, it takes the power directly out of, or it doesn't take the power directly out of. The power comes out of the generator and goes straight through goes straight to this transformer station, and after which it is basically transported out over cables overhead into the French countryside. Now, let's take a look at the news. So first, France's most powerful nuclear reactor joins the grid after a $13 billion or 13 billion euro holdup. Unfortunately, this is something that we will keep hearing, until the end of time, and that's that the EPR projects were eye-wateringly expensive. We paid a lot of money. But what I also note now is that with this shift in urgency for addressing climate change, but also this shift of urgency with this whole new geopolitical situation that is evolving, what you see also in the UK is that there's a clear uptick in speed and urgency. So that's one of the things that I want to say. So then Framatome, this is their website. Flamanville 3 is France's first Generation 3 Plus EPR. Generation 3 Plus, meaning that there is some passive safety features in there. There's a grace period, and a grace period basically means that when you have a sudden reactor shutdown and something goes wrong, the circulation stops. What happens is the system is capable of cooling itself down for a period of time. There is a passive cooling system involved in a Generation 3 Plus light water reactor. Let's see, the Flamanville 3 project is part of the French nuclear fleet renewal program. So it's a 1,650 megawatt electric plant. It is capable of producing 4,300 megawatts of thermal energy. It generates 13 terawatt hours per year. This is interesting. The reactor building is 63 meters high. The main steam temperature 290 degrees, and the turbine speed, also interesting, 1,500 revolutions per minute. Now over here, the first concrete was poured in December 2007, not 27, 2007. And what you see right now, so first divergence, I believe that they mean that it is the first criticality, the first moment when there were actual splitting atoms inside the reactor core. Now we're here, December 2024. So that's 17 years later. Finally, it is producing electricity. So here we have the details for Flamanville 1, 1330 megawatts electric. It was the construction was started in December 1979, and it was basically finished in 29th of September 1985 and starting commercial operation a little bit more than a year later. Then Flamanville 2 started construction in 1980, so it's a year after, or less than a year after, half a year later. And it started producing electricity also roughly half a year later than Flamanville 1. Now, unfortunately, Flamanville 3, the IAEA PRIS database, hasn't yet been updated. So, construction start 3rd of December 2007, first criticality 3rd of September 2024, and now we probably have the first electricity, so the commercial operation starting in December 20th, 2024. Now, this over here is an interesting dashboard. This is one of those dashboards that you can use to show that French nuclear power plants do run in load following mode. You can see at Belleville 2, you can see it in Cottenham 2, Cottenham 4, also here Chinon 1, although it's just a minor blip. The same with Chinon 3, blip, blip. You know, there's no... It's not really necessary today because this is a 30-minute interval. We're talking about a Saturday, so currently there's not a lot of demand in France to speak of. You know, most factories are done. Most people have gone home. It's nearly Christmas, so not all nuclear reactors are expected to run flat out. But it's nice. You can see these curves. Now, unfortunately, Flamanville 0 is currently not producing any electricity. Flamanville 2 is producing 1.3 gigawatts at this moment. But Flamanville 3 has not yet been put into this screen. So that's something that I mean, come on. This is the moment. We want to share this with everybody, you know. This is the moment that we've all been waiting for. I was tremendously happy when Olkiluoto started producing electricity. I was really happy when Vogel 3 and 4 started producing electricity. Now we have Flamanville attached to the grid. I mean, these are actual milestones. We are finally putting all this anti-nuclear bullshit behind us. We finished these incredible machines that produce electricity for the next coming 60, 80, maybe even 100 years. And this is something that we should celebrate. So it should be on here. I want to see it producing electricity. It's not down here. No, it's why would it be down there? This is all arranged in an alphabetical order. So this is also interesting because what France is intending to do is they are going to build at least 8 reactors in the coming years, and they want to add another 6, or maybe it was the other way around. They wanted to start building 6 reactors and add another 8 later on. So that would bring the number up to 14, but honestly, France should do at least double that, 28. If you ask me, I mean, let's not beat around the bush. We need a lot more power, and if we want to triple nuclear capacity, which France also wants to do, starting off with 24 is really what is needed, because they have around 50 nuclear power plants in France. And this means that they need to grow to 150, or maybe, somewhere between 100 and 125, 125 and 150. I don't know precisely, but that's neither here or there. They need to build a lot more. So this is interesting because I've been looking for this information on the French EDF side, but unfortunately I couldn't find it. I did find this on the Czech side for EDF. This is interesting. So over here they have these little pictures of the EPR, the 1650 megawatt electric quad loop nuclear power reactor. So quad loop means basically the primary loop. There are 4 primary loops. So you have 4 not 4 steam turbines. You have 4 steam generators. So you have 4 outlets coming out of the nuclear reactor with thick pipes that run the superheated water into these steam generators. There you have these small pipes, so this water basically gets distributed through all these small pipes, and those small pipes are surrounded by the water that's in this secondary loop. And there's a lot of space in this steam generator. So what happens is the heat to 280 degrees Celsius, water that runs through these pipes that heats up the water that surrounds those pipes. And once you get to 100 degrees, it basically flashes to steam. So that's how they build this. The steam that you need to run the steam turbines, which then generate the rotational energy that we can use in the generator to actually generate electricity. So 4 loops, right? So once this water has basically given off all its heat, most of its heat, to most of its useful heat to the surrounding water, then it is cooled down and it basically returns into the reactor, where the whole process starts again. Now, at this moment, it looks like EDF is also developing a 1200 megawatt variant of the EPR. Now, the difference, I don't know if you can see it over here. Here, there are clearly 4 steam generators. And in this building, you see 3 steam generators. So basically, what I expect is that the reactor pressure vessel, if you compare the 1650 megawatt unit to the 1200 megawatt unit, you get less protrusions. Obviously, you have less. You have one less hot leg, one less outlet, and you have one less inlet. So it's slightly different in that configuration, but it's entirely possible that the rest of the reactor, the rings and the bowl underneath and the head are roughly the same. Obviously, you would also need a lot less of the fuel assemblies inside this reactor. So the internal configuration may also be different, but they are both based on the same technology. So let's hope that this EPR 1200 can be constructed faster than the EPR. What you can also see over here simulated is it looks like a core catcher. So core catcher is there in the case of the worst thing happening. There's no more water cooling the reactor core down. In the worst case, you get the meltdown. The meltdown basically melts through the reactor core, and then it drips onto what we call a core catcher. And this core catcher basically it disperses the core, and this means that it can actually start cooling down again, and that prohibits the China syndrome from happening. Not that the China syndrome really is a thing. I don't believe that a molten core would actually be capable of even reaching 100 meters underneath the nuclear reactor, let alone get out of the building, because there are too many dispersal mechanisms in between. That's the whole thing. And then there's the Newart small modular reactor. I have no idea if this thing is still alive, if they still pursue the development of the Newart SMR. At this moment, I know that EDF is working together with Horizon. Horizon is a Dutch startup. They have been working on a molten salt reactor, not a thorium fueled molten salt reactor, but there is thorium in the reactor. Very interesting concept, mainly designed to burn radioactive waste, high level radioactive waste, plutonium in essence. So that's really interesting. And then we go to the map. So I told you over here, we have the landing beaches, right? Over here near Caen and Bayeux. Over here, this is where the Allied forces, when D-Day happened, which was June the 6th, 1942. No, not 42. It was 43. Let's see, just for 1 second. So first we go down here. Over here we have the landing beaches in Normandy, June 6th, 1944, was when, a couple 100,000 Allied soldiers made their way across the canal in order to invade France and free France from German occupation. Now, over here we have this peninsula I was talking about where Cherbourg is, and Barfleur, and I believe that Honfleur is on the other side. But in any case, over here you have La Hague, which is the nuclear center for France. You also have Tricastin, but over here in La Hague, if you want MOX is basically, that starts here, the reprocessing starts here. I believe that the fuel is actually made in Tricastin, so they have to, they move all this stuff through France towards Tricastin, where the fuel is then made, and then it moves back to our little nuclear power plant that uses MOX. But in any case, we're talking about Flamanville. Flamanville is on the western side of this peninsula. Unfortunately, they pixelize their nuclear power plants, but it's no longer as harshly pixelized as it used to be. So again, Flamanville 1, 2, and 3, the nuclear islands, the containment buildings, very clearly visible. Then over here, we have the turbine buildings, and then the electricity is moved off-site using these high voltage lines that then move the power inland. Now, this is a very large site, so let me just do a little math. So it's 3 gigawatts plus another, let's say 1,200. So it's 4.2 gigawatts of electrical power that gets produced at this site today, just because they actually managed to get Flamanville 3 finished. Also, what I found interesting is if we compare this, for instance, to Hinkley Point C, which is over here. I don't know. So let's see how much space they are using to build Hinkley Point C. So this is 1.5 kilometers. And if we take it into this direction, then it's like 1.2 kilometers, roughly, right? 1.5 by 1.2 kilometers. And if we go back to Flamanville, right, and we have to acknowledge that there's already nuclear power plants there. What we get, I mean, this space itself, it's not that big. It's like 350 meters long, and let's say that it's 220 meters wide, right? So just look at the post stamp that they're using to get this built. So let's take this area over here. It's 400 meters and it's 250 meters. And you can see, I know it's pixelated. So I guess that these buildings over here are part of the construction effort. And all this stuff here is part of the construction effort. And this stuff here is, I believe that this is less space than they needed at Hinkley Point C to get it built. But again, they took their sweet time, 17 years to get this thing constructed. I mean, we really need to be able to build these things in 6 years tops. So we really need to speed up the process. Now, luckily, France already has everything it needs, in-house. So Le Creusot, we have these two facilities over here, right? This is where they can make reactor pressure vessels, in these two facilities over here. So huge undertaking to make a reactor pressure vessel. Then we have another factory over here. I don't know what they make here, but I can imagine that it's components. As you can see, there's a lot of stuff that is over here. I mean, look at these large semicircular things. I don't know what they are, but it could be that these are part of, these are part of assemblies, or maybe part of the steam turbines, or part of the piping. Who knows? I mean, there's loads of components that are waiting outside here, waiting to be made. Also, this is very interesting. Let's see. I believe that this is it. Yeah. This is it. This is the place where the turbines are made. This used to be owned by GE Hitachi. It no longer is owned by GE Hitachi. It was bought by Framatome in order to get their in-house capabilities to produce their own steam turbines. So that's what they do here. They create steam turbines over here. And then there is, I mean, they have more factories. There's many more factories in France where they do all sorts of stuff, Again, um, really necessary. If you want to build nuclear reactors, you have to have the infrastructure. You have to be capable to produce the parts that go together and form a nuclear power plant. And that's what these factories are for over here in Turmoil, right across the German border, the Belgian border. So over here you can see France, and this over here is Belgium. So they're making these large industrial projects right across the Belgian border. This is also interesting, by the way. So I live here. There is this over here is Liège. Then we have Huy here. So there's a large nuclear power plant over here. This is Tihange. The Belgians, they are anxious about their nuclear plants as well. So they pixelate them, unfortunately. This is the Meuse River, right? And the Meuse River goes down here to Chose, or I really don't know how the French pronounce it. But here's another two unit nuclear power plant. It's in this. It's basically in this. I don't know what you would call it. Enclave? Is it an enclave? Perhaps it's an enclave. In this piece of France that juts into Belgium, basically. Again, the Meuse River. And then there's Cattenom. Let's see. I believe that Cattenom is here. Yeah, that's not the Meuse River. That's the Moselle. Unfortunately, it's a different river. They do share. They are in the same tributary, if I'm not mistaken. So you have the Moselle and you've got the Meuse River. Let's see if this is still the Meuse River. I don't believe it is. No, this is already the Seine. Yeah, sorry for this this short excursion elsewhere. So the question is, where are they going to build these 6 other EPRs, right? We know that they are currently building an EPR over here somewhere, but that's not France. Let's see, Lowestoft. Then we have to go south from there. Where is it? There it is, Sizewell. So we are one pressurized water reactor, the only pressurized water reactor in the UK. Sizewell B. Then over here we have Sizewell A. Unfortunately, Sizewell A is no longer producing electricity, and I know I've seen a picture from William Shackle, who is Shackle, who is a really cool guy from Australia, who is really trying to make the Australians open their eyes and start actually building new nuclear power plants. He made a picture. They were already doing the groundwork for Sizewell C, which is going to be a copy of Hinkley Point C over here. Now, this is such an awesome project. It's huge. It's a mega project. I know, but they are finally making headway. The nuclear reactor has been installed. I made a video about that. They also recently installed the turbine stator. So you need to make sure that the steam actually flows in one direction, and that's why you have a stator in there. It basically forces the steam into one direction. So this is finally picking up some speed. They're finally making some headway with the construction of Hinkley Point C. So yes, good days for the EPR. Finally, Flamanville 3 is finished, and now the French can actually start building those other reactors that they need. So with that, you've made it to the end of this video. Please leave a like and subscribe if you want to support the channel. Also leave a comment down below, and if you want to help me financially make these videos but also take care of my family, please make sure that you become a member of my Patreon page or become a member of the YouTube page. In any case, thank you all for watching, and may the strong force be with you. Bye bye.